Hello and welcome to my video. In this video, I will talk about converting unsigned integers to hexadecimal and then converting hexadecimal numbers back to unsigned integers. Before we can start converting unsigned integers to hexadecimal, we must talk about one thing. When we are converting and we get our remainders, we will have remainders that are greater than 9. For example, 10, 11, 12, 13, 14, and 15. Well, we can't write the digit with 2 digits, such as in base 10 we would use to represent 10, 11, 12, 13, 14, or 15. So what do? Well, when we have a remainder that is any of these numbers, we're just going to convert them to the proper hexadecimal digit, which 10 is going to be A, 11 is going to be B, 12 is going to be C, 13 will be D, 14 will be E, and 15 will be F. So now let's look at an example of converting a number in base 10 to hexadecimal. So just as when we were converting numbers from base 10 to binary, if you need an explanation of what N, M, and B are, make sure to go back and watch my video on conversions from base 10 to binary and then back from binary to base 10, which you can find linked up in the cards above on this video. But we have N, which is 427, or the number we want to convert. M, which for now is going to be an empty string or nothing. And at the end of this, M will be our converted number, and B, which is the base we want to convert to. And then we can start converting just as we did in the previous video, but this time in base 16. So we have N, which currently is 427, and we have B, which we are going to divide N by, and B is going to be 16. When we do that, we get a result of 26 and a remainder of 11, and we are going to convert this remainder of 11 to the hexadecimal digit B, and that is going to be the rightmost digit of our hexadecimal number since we are building the hexadecimal number from right to left. We will then bring down this 26 and use that as our new value of N. So let us override N to be 26, and currently M is going to be B. So if we do this again, we do 26 divided by our base, which is going to equal 1 plus 10. And again, we need to convert this number to a hexadecimal digit, which is going to be the digit A, and that is going to be the next digit to the left, since we are building from right to left. So we can come over here, we can re-overwrite N with the number 1 and M with the number AB. And well, N is not 0 yet, so we need to continue. So we put 1 here, divide that by our base, which is going to result in 0 with a remainder of 1. And then we are going to add that as our next digit to the left. So we get 1AB, and we overwrite N with 0, and then M is going to be 1AB. And just as before, since N is 0 now, we know that we can stop, and we know that our answer is going to be 1AB, or whatever is contained in M. And now let's talk about converting hexadecimal numbers back to unsigned integers. And one thing to note, we are going to have digits that are going to be characters from the alphabet. And when we do our math, we are going to need to convert these digits back to their decimal counterparts. So A will get converted to 10, B to 11, C to 12, D to 13, E to 14, and F to 15. So now let's look at an example of converting from base 16 to decimal. So if we wanted to convert this 1BF72 back to decimal, well, we would have N, B, and S, which were again described in the previous video on converting from base 10 to binary and then back from binary to base 10. So make sure to check out that video for an explanation on N, B, and S. But N is going to be 5, or the amount of digits in the number to convert. B will be 16, or the base of the number to convert. And S will be 0, or the running total of the values we are calculating. So we start by decrementing N by 1, and then using that as our first power to raise our base to. And our first digit we are going to look at is 1. So we are going to take that digit and multiply it by the base to the power of N, which will give us V, which is going to be 65,536. And then we can add this number that we got for V to our running total, which is currently 0. So we get 0 plus 65,536, which will give us 65,536. We then decrement N by 1 and use that as our new power to raise the base to. Our next digit we are going to look at is going to be B, which is really going to be 11, because we need to convert that to a decimal number to do our math. And we're going to raise 16 to the power of 3, which will give us 45,056. And we are going to add 65,536 plus 45,056, which will give us 110,592. We can then again decrement N by 1, look at our next digit, what is going to be F, and F needs to be converted to a decimal number for our math, so we are going to convert that to 15. Multiply that by 16 to the power of 2, which is to the power of N. That will give us 3,840. So 110,592 plus 3,840 will give us 114,432. We then decrement N again by 1. We're going to use that as our new power to raise the base to. We're then going to look at our next digit, which is going to be 7. We don't need to do a conversion since 7 is a base 10 number. So we do 7 times 16 to the 1, which is equal to 112. So 114,432 plus 112 is going to equal 114,544. And lastly, decrement N again by 1, so we get 0. And then we're going to look at the final digit, which is going to be 2. And we're going to not have to convert since 2 is already a base 10 number. So 2 times 16 to the 0 is going to be equal to 2. So we get 114,544 plus 2, which is equal to 114,546. And I just realized I should have been updating S all along, but remember, S would start at 0, and then it updates to this number, 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 and then it updates to this number. So at the end, S would be containing 114,546, which we know is going to be our answer. So we know that 1BF72 in base 16 is going to be 114,546 in base 10. So as you can see, we only needed 5 digits to represent a number that in base 10 we would need 6 digits. And that gap will get larger and larger as we get into bigger numbers. So when we need to represent really large base 10 numbers, it is easier to not have to use as many digits using base 16. And that is all that I have for you for this video. Thank you so much for watching, and I will see you in the next video.